live. Hi, everybody. I'm Pedro from The Defiant. Very excited here. This is episode 2 of Do Your Own Research, a new show that we have between The Defiant and IC3. I'm joined by 3 of our most esteemed builders and industry players. We have Eli Ben-Sasson, CEO of Starkware. I hope I didn't butcher your name. Ben Fisch, CEO of Espresso Systems, and Stephen Goldfeder, co-founder of Offchain Labs. So yeah, we're going to be talking about layer 2s today. I'm interested in sort of cabling us back down to earth. Sometimes the language that we use is a bit abstract in our industry. So I'm interested in obviously diving into the technicalities of what these protocols are, just the general landscape and that sort of stuff. And then a little bit of backdrop on some individual stories and how each of you got to where you're at. So I'd love to kick it off with you, Stephen. If you could sort of level the playing field for everybody and sort of explain in your own words what a layer 2 is.
Yes, absolutely. And great to be here. Thanks for having me. A layer 2, and I'll try to say this in a way that unites. So you have here representation from 2 very different types of layer 2s, and that's at least from Starkware building what's known as a ZK rollup or ZK layer 2s, and we build the Arbitrum technology, which is optimistic rollup. So I'll try to be vague in a way that can apply to both of our technologies, and perhaps afterwards we can get into some of the differences if that's interesting. But what a layer 2 does is it says, Ethereum, which is the layer 1 that we're all building on top of, is a really good smart contract platform. By really good, I mean it's very secure and it's decentralized. It has a lot of participation with different nodes and really has broad participation from different types of nodes. You don't have to have a data center to have a node. So it lends to true decentralization. The problem is, and this is sometimes known as the blockchain or smart contract trilemma, is it's hard to get that security and decentralization and also have scale on the base layer. And we know how to tweak this a little bit. So you'll see other layer 1s that go for more scale and they lose out on some of the decentralization and security. And, there are different people trying different experiments, but in the Ethereum space, we really like the security and decentralization. So we say, okay, how do we get scale? And we say, we'll get this from in a layer 2. And what it means is, so Ethereum, we limited scale, basically intentionally, right? We don't allow it to scale. And that lends, you can see how that lends directly to decentralization, because if you limit the resources it takes to verify, it means more people can participate. You don't need to have these really, really exotic machines or hardware to actually participate. So we intentionally limit the scale on layer 1, but we still need to be pragmatic. We still need to scale. We can't go to people and say, hey, it's super expensive, it doesn't have much capacity, but it's awesome, so you should use it. That doesn't work for actual businesses that are building on blockchains. So we get the scale in layer 2 world. And what it means is we basically utilize Ethereum's limited capacity as much as possible. We get more mileage, mileage for our gas, if you will, because what we do is we take a lot of the computation off chain. We do it off of Ethereum, and instead we come back to Ethereum and report on what happened. Now, remember, we want Ethereum security and decentralization. So we need to actually have Ethereum not just be an observer what happened, but Ethereum actually has to verify what happens. Ethereum has to say, hey, all that stuff you did in off-chain world, I actually vouch for it. And I, Ethereum, say this is correct. And this was processed securely and according to the rules of your chain. And so the way this is done broadly is, so a user sends a transaction off-chain. In a rollup, they'll put the data directly on Ethereum. They'll send the data to Ethereum, and they'll send the transaction off-chain. Because you can think of a transaction as two different things, right? Transaction is just like the zeros and ones, like the actual data. But transaction also is the semantics of what that means. So those zeros and ones mean something. It says, hey, add these 2 numbers, store this value, run this computation. So we put the raw data on Ethereum in a compressed and batched up way. And then we go ahead and execute the transactions, do those instructions off-chain, build up this state tree off-chain. And then we periodically and pretty frequently report back to Ethereum what happened. So the input data goes in Ethereum, the processing happens elsewhere, and we report back to Ethereum what happened. And now remember, we actually want Ethereum not just to say, okay, I'll take your word for it, but to actually verify it. And that's where rollups use proving. And not only do we tell Ethereum what happened, we prove to Ethereum what happened in a way that Ethereum can verify it, even though we've done much, much more computation off-chain than Ethereum could possibly do on-chain. That's how we scale. We do a lot more off-chain. but we have these really cool verification methods that allow Ethereum to vouch for the security and say, hey, even though I can't run all that directly, I just don't have enough capacity, I'm actually vouching for the correctness and saying, yes, this result that you posted does correlate to running the transactions you posted. So I, Ethereum, have the inputs, I now have the outputs, and these things actually do correlate. And there's two more brief things, and then I'll stop there. There are different ways to do this verification, and that's where Ellie and I have built different approaches, and others as well. There's the optimistic roll-up way, which basically says, hey, take my word for it. This is what happens. And then someone else can challenge. And if someone challenges, then Ethereum serves as a referee in what's called a fraud proof to actually figure out who's not telling the truth. Or there's a ZK rollup like Starkware builds, which actually, when you come to Ethereum and tell it the result, you also give a mathematical proof. You prove to it that not only am I telling you this result, it's correct, right? So either you optimistically accept it, and then there's a fraud proof if someone challenges, or you on demand give it a proof, and everything settles out right there. And then the last thing I'll say is, I mentioned we put the data on Ethereum. That's what happens in rollup mode. And it's really important to actually have consensus on the data. Because remember, if we're trying to get consensus on what happens off-chain and what happens in the execution, we can't even hope to get consensus if we don't know what the inputs are. So that's why we need to really know, like, what is a set of transactions we're running? And then we have a deterministic process that runs those transactions, and we can have a protocol that says, okay, what happens when you run those transactions? But if we don't actually get consensus on what the inputs are, like, it will be completely hopeless to try to come to the result of what the outputs are. And that's why data availability and data, just agreement on what the data is and what the ordering and set of transactions is so important. So the simplest and the dumbest way to do that, if you will, is to just put all the data on Ethereum. And therefore, everyone can have access to and look at the data. We put it in a way that's like compressed and just use Ethereum just as a data access layer here. But there are now, that's also, even with recent advances in 4844 using blob space for data, that's somewhat expensive. So there are lots of other alternative data availability solutions. We at Arbitrum, at Offchain Labs, something called Arbitrum AnyTrust. Ben here at Espresso also data availability solution as well that puts data elsewhere in Ethereum. But importantly, again, you need consensus on the data and consensus on what happened when you process that data.
That was a brilliant intro. I'd like to pass the baton over to Ben and sort of also continue on the sort of leveling of the playing field. If you could, share a little bit of what you think, if you agree with how Stephen is looking at how to approach the layer 2 landscape, and if you could also sort of explain in the simplest terms what shared sequencing is. I know that Espresso Systems is a marketplace for shared sequencing where different participants sort of relinquish or buy and sell the rights to shared sequencing. And even for myself, that was a bit of a mouthful. So if you could sort of explain it in more broad terms so we can understand it.
Great, yeah, and it's great to be here with Ellie and Stephen. They're really luminaries in this space, and they've built two of the most successful L2s, and we're just getting started. But one of the reasons why we're building what we're building is very much related to what Stephen was just talking about. So the way that L2s have achieved scale is by moving computation or execution of transactions off-chain. And this is generally done by some set of servers on behalf of a rollup. And so Starkware, for example, has a different set of servers that are executing Starkware transactions from the server that is executing Arbitrum transactions. And there's not only Arbitrum and Starkware, but there are now many different instances of even rollups within the Arbitrum ecosystem. I believe there are also many rollups within the Starkware ecosystem using Starkware technology, and there are even other companies building rollups that are using a different software stack. So today we're seeing a trend towards many different rollups that are each moving execution of transactions off chain. And they're all now processing transactions independently of each other. And so this definitely achieves scale, but it loses a very key property that we have on Ethereum, which is a certain form of composability. If you think about how transactions are processed on Ethereum, there is one party at a time that is elected. It's called the leader, right? And it builds a complete block of transactions that simultaneously updates all applications on Ethereum. And this block can include, for example, function calls between different smart contracts for different applications. What that means is you can have a user that does something in one application and then immediately does something in another that then affects the state of the first application again. The classic example of this is a flash loan, where a user is able to borrow funds from some lending application like Aave, use it to execute some trades in a trading application like Uniswap, make some profit, and then return the money in the same transaction or the same sequence of transactions. So this is called synchronous composability, and you have that on Ethereum. You don't have that across the different layer 2s. Now, there is, of course, some fundamental limitation to the composability you can achieve between applications that are being executed separately from one another. And we don't want to push all execution together, or at least we don't want to require all nodes that are participating in the security layer of Ethereum to have to execute all applications for the very reasons that Stephen just spoke to, which is that would overburden the nodes that are contributing to security, and it would restrict it to a more limited set. On the other hand, there is a great degree of composability that can be achieved simply by having a common party propose transactions across different rollups in a coordinated way. You can imagine a bridge provider, for example. Bridge providers, often what they do is they receive a payment on one chain, and then they release a payment to an end user on another chain. Bridge providers take the risk, however, that one of these two transactions will revert, so they often have to wait for some time for the transaction on the first chain to settle before they can release funds on the next. On the other hand, if this bridge provider acquired through some marketplace mechanism, for example, the ability to basically propose the transactions for this first chain and propose the transactions for the second chain together, then they would greatly reduce the risk that they take. And so this is a simple example why someone might want to become what I call a shared proposer or shared sequencer for two different rollups. Today, rollups generally have an appointed sequencer that is the only party that can basically propose the next transactions for that rollup. Of course, there's a technicality where for censorship resistance, often users can directly send transactions to a smart contract on the layer 1, but we can ignore that detail for now. Generally, there's this high performance server called a sequencer that collects transactions. What we're proposing, which is also in the direction that rollups are going anyways, rollups want to decentralize and open up the role of sequencer to be potentially permissionless or to be rotated among some set of participating parties. What we're proposing is to create a marketplace mechanism whereby that role can be sold. So rather than rotating among a fixed set of parties, you can actually sell this right to become the proposer on an open marketplace, and that will naturally achieve the most efficient configuration whereby parties can come in and start building and coordinating construction of transactions across different rollups. You lose some properties by opening it up to a very open marketplace. So we're also, I don't want to get too much into the weeds on this, but we're also working together with Offchain Labs on a sort of middle ground solution between these two extremes, where there's a more restricted set of parties that are trusted not to front run transactions, and they are basically going to be entrusted to construct transactions for rollups that use this solution. But they will sell not entire sequencing rights, but just a priority lane, like a fast lane, that on an open marketplace that that anyone can come in and control. And so you can imagine if you control the fast lane of transactions across many different rollups, that will already enable you to do pretty cool things across those different rollups.
Interesting. Eli, I'd love to put you on the spotlight here and ask you, there's different types of rollups like Stephen and Ben have explained or outlined. And I'd love if you could do a sort of dive into why at Starkware you decided to pursue. I know this is obviously, and I want to tag in sort of the idea of interoperability being more of a moving target or a sort of phenomenon that can happen between different chains in different ways. But I'd love if you could give us a little bit of insight as to the direction that you've taken at Starkware in the sense of ZK rollups and why you sort of decided to prioritize or start building in that direction, and not, or if that's still an open conversation that you're having for other sort of solutions where you saw the pros outweigh the cons and take your company that way.
Yeah, so I've been in this space since 2013. Basically, I came from the academic world. I was doing research and math related to proof systems. So, you know, I and Starkware, we have a deep passion for that particular technology. But, and we've been scaling, you know, with Validity rollups and in particular with Starks since we launched the company in 2018. There's a lot of discussion today about how proof systems, I mean, I know they're called ZK rollups, but I have a hard problem calling them ZK rollups because most of them don't actually offer ZK, which is about privacy. I think I probably have a little bit to blame for that because the way proof systems enter blockchain was because of Zcash, which does actually have privacy that at its core. And I was also one of the founding scientists of Zcash. So I understand everyone calls them ZK rollups, but I will stick to validity rollups because it's not about privacy, not yet. Okay, so since 2018, we believed very strongly that proof systems are really a very good match for scaling blockchains, all kinds of blockchains. And I think among proof systems, the particular family of Starks is best at scaling and has the, you know, is the most future-proof in terms of its minimal security assumptions and fastest speed. And we've been saying this since 2018. You know, I love pairing-based snarks. Zcash is based on them, and there's amazing math behind them. But when it comes to sheer scale, nothing outperforms Starks, especially when they come and are deployed in very small fields and small integers. So we strongly believe in this technology as a general purpose, good technology for scaling and for offering integrity in cases where you don't trust the other party. It's just a very basic technology that I think no one on this call doubts that it should go in a lot of places. And, you know, we all should aspire to the day when, you know, banks and governments basically, when they make commitments to customers or to individuals, they support that, first of all, with transparent code saying this is what we stand by. And then this code is enforced and verified using proof systems. I think, you know, we'll get there in, I don't know, a decade or two. And we'll get there through blockchains. So we strongly believed in the merits of this technology of Starks to scale. And we've been at it, you know, we deployed our first system in production in 2020. And for a very long time, this was the main and biggest source of scaling on Ethereum, period. So, you know, through the StarkX system, again, that was deployed on Ethereum already in the summer of 2020, we minted, you know, by now probably over 100 million NFTs. This goes back, you know, more than 4 years. At the height of the NFT craze, where people were paying, you know, $40 a pop, Immutable X and Sorare that were using us paid, you know, less than a cent. We, you know, reduced cost by a factor of 20,000. Then what happened was we just realized that the internal tools we've been using can be actually made accessible to developers all around the world, which is how we came about working on Starknet. And what we did is made accessible the very best tools that we were using. So, we first of all ate our own dog food, including the programming language Cairo that we use to build all of our systems, and which leads to the greatest scale when it comes to validity proofs. And we said, okay, the world should have access to this technology. Now, what are the merits of validity proofs? First of all, things like fractal scaling, which means that you can not only run a layer 2, which is what we're doing now, but you can deploy layer 3s, which can then deploy layer 4s and layer 5s. And the nice thing is that they all basically inherit the integrity of layer 1, because you never update the state without having a proof that ultimately settles on layer 1. So you could have something that is very hard to have by economic means or even by fraud proofs, which is you could have these recursive layers where people basically take a whole bunch of computation off chain and come after a day or a week and say, here, we can prove you haven't seen what happened, but you know that what happened with integrity. So that's one thing that these things offer, which is really important for massive computation. Another aspect, even though I was complaining about the use of ZK for ZK rollups, these proof systems can be turned on with zero knowledge. We haven't done it yet, but we will do. And then you also get very high grades of privacy. So you could have a whole layer that is working, and customers have privacy for them. And it also leads to very low settlement time, with respect to things like fraud proofs and so on, with very little or like no economic assumptions or no need to monitor. It's basically based on cryptography and math. So I think these are very, strong technologies that have a place, not just in blockchain, but in something bigger that should permeate to all of society. We like to talk about how we're all building this thing, the integrity web, which is like a layer on top of the World Wide Web, but which assures all of us that the right thing is being done even when we're not watching, and where promises made by entities are not, are upheld by external parties, and they need to stand true to the words they made. So it's even bigger than what blockchains are today.
I'd love to touch on something that's sort of transversal to the three of you, that you all come from an academic or have some sort of academic background or context. And so, Eli, I'd love to sort of tag on to that and see how academia has helped sort of shape your understanding, not only of just the general Web3 blockchain world, but also the roll-up world. And if our industry, because I know that academia can sometimes get a bad name in today's world, but how we can sort of inherit some of the good practices that does take place in that sector of society, to sort of push us forward in ways that we want to go forward.
So some things that I think definitely we took with us from the academic setting. Well, one is a whole bunch of technologies, right? You could never have validity rollups without the 30 to 40 years of amazing research done mostly at universities by brilliant researchers. I personally spent 15 years prior to founding Starkware, basically inside the academic world, learning from the great masters and contributing there. So a whole bunch of technologies came out there. And of course, also things about, tokenomics or microeconomics, right? They have rootings there, consensus protocols and peer-to-peer networks. So many of the different technologies and components of blockchains, the technological ones, of course, owe a big debt to academy. But in terms of like values and spirit, one thing that I think is very strong in at least the branches I traversed, which are very related to math, is meritocracy, which means, the rule of excellence. In math, it often happens that someone completely unknown and very young, proves a major theorem, and then, he becomes one of the great ones there's no you go into a hierarchy and so on. And I think blockchain is very much like that, in the sense that, it's not corporate world where you sort of go up the ranks and, experience matters a lot. It's really people who shine in terms of their personal excellence. They go places. Same things with, teams and so on. There's also a very high level of transparency and sharing of ideas, again, which is like, there's not a lot of use of IP protections and stuff like that, which is, again, a bit like in the academic world. So I would say that those two things are, the sharing and transparency, and the understanding that with all the competition, we all sort of advance each other, and that's good. That's something that you get also in the academic world, and then the meritocracy.
Stephen, I don't know if you want to add on anything there in the sense of how academia is also sort of, paved or laid a foundation for what Offchain Labs has become. And then I'd love if you could also going sort of backwards and taking maybe a short trip down memory lane. If you could give us sort of, an insider look into how those early days were at Offchain Labs, especially in the Ethereum community, how understanding that maybe scaling needed to happen off-chain, why it should happen off-chain, what those conversations were, what was the pushback, and I think it'd be interesting if there's still pushback that you get today that you were still getting back then, that people may be sort of struggling to really understand why we sort of need this layer 2 landscape, or why this has been the route that Ethereum has taken as just a general ecosystem?
Yeah, so those two things are very connected because like Ellie and Starkware, we emerged from, in our case, Princeton University research. So my co-founder Harry and myself were PhD students at Princeton, and Arbitrum was one of our projects, and Ed was a professor there at Princeton for about 30 years. So if you go back into memory lane a little bit, so if you actually look on YouTube for the very first mention of Arbitrum, I used to say just look on YouTube, you'll find one video about Arbitrum, but now there's just quite a bit more. But if you look back for that very first one, you'll find a 2014 class seminar, Princeton class seminar, like a final semester project video. And you'll find a bunch of undergrads built the project under the leadership of Ed. I was actually in the class doing something different about MPC wallets, but Ed was leading this project on Arbitrum. So the history is Ed had this idea. And the reason I like to mention that date is because Ethereum went live around 6 months later in July of 2015. So really from the earliest days when smart contract platforms didn't exist, but they were theorized, there was academic literature talking about them. Ed was very early on, one of those people that were very early on and realized, hey, that like these platforms have limitations. So if this theory takes off and becomes real, there are going to be problems scaling this. It's not going to work. It's not going to meet the demand. Ed went off to the White House for about 2 years, for the last 2 years of the Obama administration, and Arbitrum kind of just sat there on the shelf. When he came back, Harry and I went to his office and said, hey, we should pick up that thing. It was about 2017 at the time. We were starting to feel the initial pains of scaling. If you remember, like the CryptoKitties era. And it was like, okay, we need to scale. Like, again, if you look back, like this looks like a little bump and looks like a nothing. But like at the time, it felt like, okay, this is starting to take off. And of course, we've only done a lot more since. So we said, okay, we're going to build Arbitrum in the academic context and really build it out. The undergrads sort of went with it for a semester, and we're going to build it out fully. So we did that, spent a year and a half or 2 years on that, and published that paper at Usenix Security, which is one of the top security venues, in August of 2018. That's also the month that we launched the company Offchain Labs. So none of us had any plans of ever doing anything. Certainly not in our own company, a startup land. That was like far out. But as we built Arbitrum, we kind of realized the importance of getting this right, because, echoing some of the things that Ellie said, the ideas all came out of academia. And in academia, there is a meritocracy, and the best ideas win. And we all came from this notion of we want to do it, we want to build it right. And we didn't want to make compromises and sort of, put the tech or the security as second fiddle. We really wanted this to be done right, and we said, okay, we want to build this ourselves, and we formed the company. Definitely, and interestingly, actually, even if you look back to today, some of the core ideas, there's been lots of different differences, but some of the core ideas in Arbitrum, particularly around the interactive fraud proofs, date back to Ed's, very, very early ideas. Obviously, there are a lot of other things that have changed as time went on, but the core is actually very, very much, at least theoretically, the same. In terms of pushback, I remember getting on early investor calls. So there were two forms of pushback. There was number one where people said, and this is like 2018 ish, where people said, I believe that scale is going to be important, but it's definitely not our important problem now. I think we have, many other important problems, and we have time for this. Solve usability first, and we'll talk about scale later. But of course, usability and scale are very well connected. Ironically, so we took our time to build. Arbitrum launched in 2021 August, and we took time to really, get it right and iterate it. But by that time came along, people were like, where are you guys? How come you haven't built this yet? And the same people that back then were saying I don't know if this is so much of an issue. We're like, where is this? We need this today. And that's actually a really important thing to realize, where it's important to sort of be early, because people don't price it in. People are either in the mode of we don't need this, or we need this now, and why isn't it built yet? So actually being early and building something when people don't realize they need it is important, because then when they do realize that they need it, it becomes you're there and you can actually deliver that. And in terms of other pushback, this is another interesting one. I remember going into early investor calls, and the question that we always got was, are you a state channel or are you plasma? Right. So these were two early Ethereum scaling directions. And the point is, in 2018, in many people's mind, it was already settled. The way that Ethereum smart contracts will be scaled is either with state channels or with plasma. And we had to actually say, no, we're kind of this other thing. It's called Arbitrum. The word roll-up didn't exist yet in this context, so we didn't have that. We're like, no, we're not either. But actually, at some point, I kind of gave in. So I remember at the 2019 Cornell Tech, this is an IC3 call, I should mention that. So I was at IC3 as a postdoc also, and definitely was very pivotal for the people that I met, and some of the research that I did, particularly around fair ordering and fair sequencing, came right out of IC3. So I was very fortunate to work with Ari there. But I remember that year when I went to IC3 bootcamp, I gave a talk called Arbitrum Advanced State Channels. And I just basically recast Arbitrum in the terminology of state channels, because it turned out that people felt that that was necessary. And I remember actually going to Vitalik at that event. That was the first time I met Vitalik. It wasn't the first time I met Vitalik. It was the first time since I was working at Arbitrum that I was talking to Vitalik. And I'm like, can I tell you about our state channels project? Right. So I guess the lesson there is, and we sort of pushed and eventually gave up this term in favor of the term roll up. But the idea is that even today, there's so much confidence among certain people around, we know everything today, and we know what we don't know, but we know what the box looks like, right? We know that will be state channels or plasma. We don't know exactly how to build these details. We can have innovation here, but we know what the shape of the innovation looks like. But I think that that clearly wasn't true if you look back 5 years, and I also don't think that will necessarily be true if you look forward 5 years. So having important people that are willing to think outside the box, and people willing to think how can I scale this, or build shared sequencing marketplaces or the and build other technology that's helpful, but not necessarily directly in the four corners of what we think today is important. And if you go to, if you raise funds and try to raise funds or try to talk to people in the industry, you might get pushback because people feel no, it's all been figured out. But if you have a good idea, keep going with it, because eventually that box will expand.
I appreciate that beacon of hope for maybe the builders that today are sort of struggling with that. And yeah, I remember in the early days when I got into crypto also, I got super into Omasego, that's now rebranded as OMG Network, and it was just super plasma and everything. All the conversations everywhere was plasma. And it's been such an interesting shift over to rollups, and how that's really sort of become the prime way to sort of scale Ethereum. And yeah, in that sense, I'd love to ask you, Ben, how you've been a sort of player in that conversation, if you had that sort of, or maybe you were a person that in the early days, in your early days, was more plasma driven, or if you always thought that roll-ups were the way to go. How were you viewing it, especially because you sort of live in a camp that's not necessarily a layer 2 itself? You're in a different sort of, I mean, obviously it's all part of the same ecosystem, but I guess you're not exactly a layer 2. So I'd love to get your perspective on how you view it, and if you sort of, I mean, you don't have to, obviously, you've already said that you're working with some stuff with Arbitrum and Offchain Labs, but you don't necessarily have to commit yourself to one scaling solution, but how you're viewing just the general landscape.
By the time that Espresso started, it was already clear that rollups were the scaling solution that was taking off. So, with respect to Espresso, we didn't have any kind of say or particular influence in that direction. We built a product in response to what we saw as a fragmentation issue across many different rollups, and a trend where many applications were deciding to become their own rollups, not even or L3s on top of other rollups, instead of being applications within existing rollups. So, I mean, with respect to I was also a part of the industry at the time when Ellie and Stephen and others were proposing rollups, and I thought they were great ideas. I never worked on plasma or state channels specifically. At that time, I was mostly focused on other things, but I was working on cryptographic proof systems. And so I was certainly very excited by the product that Ellie was building. And I thought it was a brilliant, fascinating, application of cryptographic proof systems that would obviously take off. And it did. So now, coming back to the latter part of your question, can you remind me?
Yeah, I just wanted to see if I mean, obviously rollups are the sort of in the lead, but do you think that they are, do you think that's been the sort of, I don't want to say the correct way to go, because obviously there are pros and cons to other scaling solutions, but do you think that there is that the focus on rollups has been a correct direction to take? And I'd love for you to give me the sort of counter argument to that, why somebody might push back against it and say, no, rollups might not be why we want our layer 2 direction to go, and maybe we should be putting some more focus on plasma, state channels, or other sorts of directions.
I think what Stephen said was correct, which is you can view, and it sounds like you gave a talk on this, Stephen, at some point, but you can view what rollups are as sort of an evolution of that idea. So, I mean, sort of going back to first principles, the reason why scalability is an issue is because of different types of bottlenecks that arise when you're trying to run one massive computer for the world, right? And often when you remove one bottleneck, then something else becomes a bottleneck. So the first bottleneck for running a computer that the entire world needs to run is computation. And if you're trying to make this computer something that is very, very secure by virtue of having many, many nodes participate in running it, then as Stephen was talking about at the beginning, either you limit the number of instructions this computer can process per unit time so that it's easy for people to participate in verifying it, or you have a separation between those who are driving forward the progress and those who are verifying. And what you end up with naturally are proof systems, right? So the roll-up architecture is the idea that the world is naturally heterogeneous. There are powerful computers and there are weaker computers. We want to get as many computers in the world to participate in contributing security and integrity to the system. So let it be really easy to verify that instructions were computed correctly. But then let's leverage the fact that there are some powerful nodes that don't actually, it's not actually that expensive for them to run on high power machines. It's just not something that everyone in the world can access. Let them make really fast progress in terms of executing many instructions, and make it easy for the rest of the world to check the integrity of what happened. I mean, I almost think that by definition, rollups are the scaling solution for Ethereum. If you look at the problem as trying to remove computational bottlenecks. What we then come to is once you remove computational bottlenecks, how do you remove communication bottlenecks? Because once you make computation cheap, then the data that needs to be communicated among all these nodes becomes the bottleneck next. And that's where we don't necessarily have one unified idea of how this should be done, right? So some people think that rollups should post all their data to Ethereum, but then there are these other alternative data availability systems that maybe trade off some efficiency or security properties. And then there are also future research directions of how to make Ethereum more communication efficient. And this is the whole danksharding design. And finally, there are some, and I'm in that camp, who think that we don't always need to just modify the way the Ethereum protocol works in order to become more efficient. What you can do is you can build alternative protocols and get the same nodes that are running Ethereum to run those protocols. And this is why I'm excited actually about EigenLayer, because EigenLayer provides a very nice bootstrapping mechanism, which allows for nodes that are currently running the Ethereum software to participate in running other protocols. And this makes it easier to innovate on what the nodes that are operating Ethereum do. There are other pitfalls of EigenLayer, and this is sort of maybe getting into the more controversial territory, but I hope that summarizes sort of my position on rollups. I think rollups are sort of by definition the way to scale Ethereum, but there are many challenges that still remain once you remove computation as a bottleneck. And there are also interoperability challenges, as I was speaking to earlier, and so there are still many parts of the rollup architecture that haven't been solidified and may change, and I'm doing my part to sort of influence that in the direction that I think is best, but other people are taking other directions.
Espresso Systems was looking at a sort of, in the beginning when you guys were doing a bit of more R&D perhaps, or in those early days, you were really focused on privacy, regulatory compliance, and sort of finding the balance between the two. I know that privacy is a big issue in the digital age. Some people just say it's an oxymoron. It just won't be able to happen. It's a nice hope, but completely out of the question. Do you think that, how have you viewed that now? Has your idea of privacy shifted over the years? How do you think that we can ensure long-term scalability while also maintaining privacy? And is that a conversation that we should be having a lot more, and it's just sort of getting tossed under the radar, maybe because we're more focused, like Stephen said, on usability, or there's more focus on UX UI, or how do you think about privacy in these sort of layer 2 innovative interoperability protocols in today's world?
I think that privacy is important, first of all. And yes, that's right. Espresso was initially building a privacy product, and we pivoted to building something else. One of the reasons for that was simply the difficulty of finding product market fit for privacy-oriented products in today's world. There's a lot of there's a lot of regulatory uncertainty to begin with in the blockchain world. So building a privacy product is quite challenging. And our angle was in particular trying to balance regulatory oversight and privacy. So we were targeting, companies like stablecoin providers like Circle with USDC, and we were trying to create something that would be in between, Zcash and something fully transparent, where Circle could hold, view keys for USDC, and people could make private transactions, but have certain, policies and certain parties that would be able to uncover information when needed. It's very difficult to pull that kind of product off in today's environment, but today may already be different than a year and a half ago or so when we pivoted. With respect to privacy and L2s, so privacy is it's somewhat orthogonal from L2s, as Ellie was alluding to earlier, right? On the other hand, privacy, one problem with privacy, building smart contracts that are private, for example, on Ethereum, is the expensive nature of verifying zero-knowledge proofs. Or if you even want to go towards private smart contracts that use fully homomorphic encryption, then things get even more expensive. And so what layer 2s do is they make things much cheaper to do. So in this way, privacy and layer 2s are complementary because they massively reduce the gas costs of doing computations. And so even when we were building a privacy product, instead of running it on Ethereum, we were going to run it on Arbitrum, right? Or potentially other layer 2s for the very reason that it became much, much cheaper to run proof verification there.
Eli, do you agree with that idea, especially being one of the chief scientists behind Zcash, which I think is one of the, if not the, well, aside from Monero, is one of the only privacy-focused protocols that exists in the crypto world. But do you agree with that? And being building validity proofs, but obviously misnamed as ZK rollups, do you agree with that assessment of the privacy sort of landscape in crypto? And what do you think that other layer 2 solutions should be doing at the same time that you might not be seeing, or even conversations that you aren't even seeing in the sort of general, even going a bit further in the general interoperability landscape as well?
Yeah. So first of all, yes, I completely agree with Ben. I think the biggest problem with using privacy tech is that the UX becomes really, really difficult. So part of it is that the computations are more complicated, but other parts are just that, the combination of smart contracts and, general computation, and then which parts you want to preserve. Like, let's put it this way. It's relatively easy from a technological point of view to slap a ZK proof on computations. For instance, the Starks we have, it's relatively easy to make them into a ZK Stark. But it still won't give you privacy because the nature of the statements being proven reveal like all the information that one may care about. So you need to go one step further, which is what we did, let's say, with Zcash, and move to like some sort of shielded UTXO model that then complicates things. And the biggest issue with that is just that the UX becomes much worse than it is for standard blockchains, which already suffer from pretty lousy UX just because of the nature of self-custody and how different it is from when you just trust some big player to run things for you. So which leads me, what are the things that probably all of crypto and of course L2s need to look at? I would say just, UX, and a question that I guess definitely I'm spending a lot of time thinking about, and I guess we all are, is how does crypto as a whole go beyond, the current use cases, which if I survey all of them, my friends and family who are not already crypto, not early adopters, they won't use any of them, right? If you're not very speculative and technological, you're probably not going to use DeFi. And if you're not a very certain kind of gamer who also loves early stage technology, you're not going to do gaming. And if you're not, again, like an early believer, you're probably not going to just touch the social fi applications today on blockchain. Just because they're sort of very new and nascent. And I do think a lot about how, we all believe that, let's say 5 or 10 years from now, my parents, my friends, they're going to be using blockchain infrastructure, let's say daily or weekly for a bunch of stuff. So a good question is, how will that come about? I know it's not going to be DeFi, and probably it's not going to be gaming so much. I don't know, maybe gaming, but certainly not DeFi, not for most of them. So I think the most burning question is, what do those like mundane, applications that everyone uses are going to look like that will just bring on a lot of people?
I think that you raise a really good point and really interesting, which is this sort of long-term hope, which is mass adoption. And then there's this also like sort of counterintuitive idea that all of these protocols are going to be working in the back end and we're going to be interacting with other style things. And then a lot of these technicalities are just not going to have much to do with the everyday user. But yet here we are constantly talking about mass adoption and these sort of state fragmentation and state channels and sort of these big abstract concepts and how we can sort of bring them down to the everyday user. Is that something that you think about as well, Stephen, about how to sort of make the protocol, the conversations, the general UX UI closer to people who aren't in crypto today? Or are you still really focusing on that really early adopter? And is that, I mean, obviously it's a moving target and who knows where it's going to be in a year, 3 years, 5 years, and maybe, the company just pivots or anything can happen along the way. But is that something that you're always have your eye on? And is that something that the layer twos in general are sort of overlooking, sort of the focus on these really early hardcore crypto native adopters while the sort of moving target of mass adoption just continues moving?
Yeah, so I think we've done a pretty good job on getting the crypto native adopters excited about what we're doing. And, I'll take gaming, as Ellie mentioned. Gaming is a good example. Like if you go back to, roll back 5 or 6 years or maybe a little more, there were blockchain games, but they weren't very fun. But that was okay because the audience that they were really appealing to were those that were like, they liked the blockchain. So blockchain was number one. And then like, oh my God, this is so cool. I can play a game on Ethereum, right? And that was the audience. And it didn't bother them that it was expensive. It didn't bother them that when they pressed the button, there was a spinner that showed up for maybe 15 seconds, maybe more, maybe less, right? The user experience by any traditional gaming experience would have been terrible. But like the audience that was appealing to were these crypto native gamers. We're definitely seeing a big shift today when it comes to that. And in particular, even in gaming, we're seeing now AAA studios building on Arbitrum, right? So one very popular game in Arbitrum to call out is a game called Pirate Nation. This is an incredible team. They're doing crazy numbers, and they're the founders of Amit was one of the founders of Farmville building this, and they're building just an incredible game that's actually appealing to real users. Zai, Treasure, and others on Arbitrum are doing very, very similar thing. Apechain, and I'm not going to, I can go on, the list is long, but the idea is that you have these like gaming ecosystems now that are actually going gaming first, and number two is blockchain technology. I think that's actually very healthy, right? So, the example that's often said when I go and order an Uber on my phone, I don't like think about the underlying bits going over the wire. I just think I'm on my phone, or yes, I'm using the internet. Yes, I'm using the TCP/IP, SSL, whatever stack I'm using. I don't actually think about that. I just think about I'm going on my phone and ordering this, and that's what you want to get to. And it leads to a little bit of a philosophical question and like a problem, which is, well, we know how to build games in a centralized way, which is what many of these people might care about. We think we're doing something that's better and that's important, but how do you appeal to these users and not dilute the message and not like, and you actually, I think we on this call are actually very all aligned, and part of it is coming from that academic background and really believing in the importance of what we're doing. But there will be some that will sell you this technology in a way that's kind of centralized and kind of prioritizes growth and doesn't really have that. And if that's what some users want, it becomes even more appealing. I think that there's a reason, right? So having decentralization and security are important. It might not always be apparent. Sometimes there's an event, right? Like FTX event was a really good event that like made people think about, oh, I see the importance of decentralized systems. I don't hope those events happen again, but it's really upon us, very important upon, us on this call, but more broadly us that are building these systems to stay true to those values and to also deliver a good experience, a user experience at the same time. I think one other shift that I'm seeing a lot, which is, books could be written and like man years were spent arguing about some of the more esoteric properties of the technologies that we've built, but in ways that your average user doesn't care about. So, we can do a whole another episode where the three of us argue about optimistic rollups versus ZK rollups, and we can go on. And Elliot and I have done that in the past, and it's something which we feel very passionate about and have lots of thoughts about. But like ultimately, that's not felt by users, right? Users, they want to know, can I build on this platform? Is it secure by some metric? Should I trust you? And that's one shift which we're taking. So we have Arbitrum Stylus launching now, and Arbitrum Stylus puts new tools in the hands of developers. It gives them language support that they never had before, so Rust and C and C++. And I know, obviously, Ellie and Starkware has done similar work, really innovating on the language layer and making things more usable. I think those are the things that are going to actually pay off long term, where users and now the developers have new tools, users have in Stylus, 10x cheaper transactions. I think these are things that are going to become very, very important when it comes to scale. And I do think we're going to see a host of really interesting and important mainstream applications. One thing which we didn't touch on, which I think is going to become very important to average users, is payments, right? When you speak to people that have to send payments cross-border, there's so much inefficiency, bureaucracy, often like engineered because there are middlemen that intentionally don't want to be cut out, but we have an opportunity to rewrite that script and write it in a way that's open innovation. I think that's going to become very important. And the last thing I'll say is privacy, I think, is another one which we have the ability to, as we build the technology, innovate on. Just to call out two protocols in the Arbitrum ecosystem that are building really interesting private solutions. One of them is Renegade, which is using building a dark pool DEX. So they have your trades aren't visible, and you have guaranteed execution pricing based on Binance. And interestingly, echoing what Ellie and Ben said, the ZK here is actually happening on the application layer, and they're finding that Arbitrum Stylus, where they can write their verifiers in Rust, is really well suited to build the ZK application. So a lot of that technology that folks like Ellie pioneered, is not only going in to the architecture layer where the ZK isn't being used, but it is actually being used at the application layer as well on chains like Arbitrum, and also another one is Phoenix, which is using fully homomorphic encryption to build privacy into the chain layer. These are experiments, they're early on, but it's really incredible innovation that I think is going to be increasingly important over time. And I think over time we will find that product market fit, which, as Ben mentioned, definitely has not been there historically for these products.
I know that we're running up on time. I know that, Eli, you have a beginning of Sabbath, so I'd like to sort of close this off, and I'd love to ask if each of you just quickly can give your sort of most bullish, or not most bullish, but what experiment are you seeing in a really early phase that you're most excited about? Just like a rapid fire around. Ben, I'd love to start with you. And then move on to Stephen, and then finish off with Eli, if that's cool.
Yeah, I think that what I'm bullish on is sort of moving towards chain abstraction, and I think this is really important for this future that like Ellie and Stephen were depicting, where in 5-10 years from now, like blockchain is just being used and integrated in a very normal way, and then people who are not DeFi experts or gamers are using it, and that can't. The way that we've scaled the system, it ends up with a lot of infrastructure, and that all has to be sort of abstracted away. And that's part of why we're building what we're building. We see that as like a part of moving towards that world where you just have users that are sending cross-border payments, and they don't realize if they're on one chain or another. They're just sending payments to each other, and it works.
Interesting. Stephen?
Yeah, for me, I think the thing I'm really excited about is the execution scaling. What we're doing now, as I just mentioned, with Arbitrum Stylus, which is both giving new tools to developers, so language support like Rust and C and C++ to developers alongside EVM and fully interoperable with EVM, but also giving you about 10x bump in execution efficiency, so lower cost, more bandwidth, two sides of the same coin. And the reason why I'm excited about that and execution scaling generally is there is a certain class of applications that are sort of priced out of blockchains today for two reasons. One is like if you want to do like advanced cryptography or like AI evaluation on chain, like A, the code doesn't exist in these languages, and B, like even if it did, you wouldn't be able to run it. So sort of using the same hammer to solve those problems, I think is going to not only make current applications cheaper, and which is great and more open and accessible, but also open up a new scale of applications around things like privacy and which require lots of proof verification and some of the other things we touched on, which I think will unlock some new paths to mass adoption.
Interesting. Ali, just to close off.
Yeah, two things I'm very excited about with regards to StarkNet. First of all, the progress we're having on Stu, which is our next generation prover based on Circle Starks. It's surely going to be the fastest prover out there, but like the benchmarks that we're seeing, and we'll share a lot of information at ETHCC, are just mind-blowing and open up a lot of activities and possibilities that we didn't dream of before. And it's like reaching production very quickly. So just that's one thing I'm very excited. And something that basically goes very well with it is that, we started working very hard on seeing whether you can put the Stark verifier on Bitcoin. And we're very optimistic this can be done very efficiently if OpCat is adopted. So we're working with a lot of amazing leaders in the Bitcoin community to see if OpCat makes sense. And in parallel, we're already working with researchers from other projects on seeing how efficient is the Stu verifier on Bitcoin with OpCat. So this Stu thing, both for performance and also for the Bitcoin, putting StarkNet on Bitcoin, which we have committed to do within 6 months of adopting OpCat. I guess those are very exciting things on the horizon.
Yeah, I think you opened the field for a follow-up at some point, because the sort of OpCat Bitcoin conversation or topic is something that I wanted to touch on. But yeah, time has run out. And but yeah, thank you, each and every one of you, so much for your input, for everything that you guys are working on. Super fascinating stuff. And yeah, really appreciate all the listeners and viewers who tuned into this conversation, and looking forward to what's in store for the next 6 months. Take care, everybody.
Good to see you, Stephen and Ben.
Likewise, great to see you. Shabbat shalom.
Yeah, thanks. Same to you. Bye.